Okay, today we will talk about material modeling. So before simulation, we need to model certain geometry or structure. It is, of course, it depends on the research area or the material which we are working on. So, for example, uh, uh, if there is some experimental work and I want to reproduce that data, so how can I do that? So you need to follow all the parameters which experimentally they are using. For example, if temperature dependent work is there or something, or surface deposition or absorption or interaction or mm, certain kind of diffusion, so interstitial or uh, surface diffusion, so that kind of work. So okay, so we will follow that. So material modeling, so there are a number of software which are available to model the required structure. So JMOL, Vesta, Excel, Camera, Material Studio. These software, in these software you can model any structure from simple to complex. So it depends on the study you want to perform basically. If it is solid interaction or deposition or whatever, absorption or solid gas interaction, solid liquid interaction or liquid gas interaction or gas gas interaction, whatever, or surface interaction and molecule molecule interaction. And possibility are there, substitutional or interstitial interaction and so on. So these are the here I will show you only three different visualization and modeling software. So you can see this purple and the pink color software. Here you can see the Vista VESTA, and this is the VMD, Visual Molecular Dynamic Open GL display, and this is the Material Studio. So let's try to do something, demonstrate this for you so that you can understand. So let's suppose, for example, if I have the Material Studio, so you can take a CD, insert it, or if you have the this Material Studio in short form, so you can just click on it, run as administrator and install it. So that installation is not that big problem. Okay. And if you want to model in structure, so let me open this Material Studio for you. So this is the Material Studio, and you can download it from the website. Nowadays it is available. So here this is the Material Studio I can open. So I already installed it actually. So for that reason, when you first time open it, so you need to create a folder for where it will save all the data. So let me show you. This is the file you can import. So in the import, there are here is some store data. Store data means that there are some structures which are already available in its library. So structure, so you can, if you are working on catalyst, or if you are working on ceramic, glasses, metal oxide, metal, and there are number of. So let's suppose this is catalyst. So catalyst is heterogeneous and homogeneous, but here the available library, there are some example structure which are heterogeneous type catalyst. So let me go to the metals, and in metal there are pure metals. So the already display structure is the silver, okay, pure silver, this one. So I am clicking on it, so here it will open. Here you can see. Now you can change whatever you want to do. So let me first show it display style. So here it is in the line form. So I will select. Here you can see that line is already selected. So I want to select ball and stick format. Here you can see. So this is the ball and stick. And for actually something which I am showing you that you can change due to when you are preparing figures for the manuscript. Okay, so here you can see this is the cell boundaries, so which is in white color, so I will select black color. So here you can see now it is black. Okay, or whatever color you want to do that. So if I want to save this structure as it is, so first I will need to go to the build. In build you can click on symmetry, and in the symmetry you can make it P1. So if it is P1 symmetry, then you will observe that when I save this file, so it will be as it is. Okay, so here the Material Studio format is the with the extension .xsg. Okay, so you can export these coordinates in different format. Okay, so here let me show you that, for example, if I am saving it in the PDB format, so let's save it. So it is exported, so let's check it. So documents, so you can see AG2 here. Okay, so let me I will take the structure again to the Material Studio, and actually I want to show you that if you save it in the PDB format here, window, and I am tiling it vertically, so I can visualize 3 or 4 or different structures. So here you can see display and ball and stick. Okay, so ball and stick. So here you can see that there are basically in this structure, basically there are 4 atoms. Okay, but here you can see that there is no periodic boundary, but in this structure you can see the cell boundaries are periodic boundaries. So if I click on it, so I will go to the view and project explorer, sorry, view project explorer and view uh, properties explorer. So here I can click on the properties of this material. So here you can see when I click on this screen, it shows that there are 4 atoms basically. Okay, so 4 atoms you can see on the corner, you can see it is 0.25 contribution, and on the side it is 0.5 contribution. So uh, you can see, okay, let me move it, so you can see here. So 4 atoms are here on the top at the corner and 4 are at the bottom. So when you multiply 1 by 8 into 0.25, so it becomes 1. Okay, and here this is half, so 1 and 1 2, and this is half, so 1 3, and this one is half of contribution. So from the side it is half of contribution. You can see this is half, this is half, this is half, and half is outside. So this is the total number of atoms in this unit cell is, this is basically unit cell. So you can see that number of atoms are 4. So if I save this file as a PDB without making it P1, then it will show me 1 atom only. But if I make it P1, then it will show me the 4 number of atoms which exist in the unit cell of silver atom. And you can see here it is a simple cubic structure because all the sides are equal. Okay, so now also if I want to see the what is that, the coordinates. Okay, so here I will click on this, and if I click here apply, so you can see here, so you can see that each atom has 3 coordinates. This is x, y, and z. Okay, even though I can change this color also. Okay, So actually the let me first open display and okay, not in here with the label. Here in the label, I label it with the XYZ. So here I can change the color. So let me take it red color, make it red color. So it becomes red. Times like 60. So here and XYZ. So you can see here. So you can increase the font size, the number if you cannot see. So basically these atoms, this atom has the position 0, 0, the x position is 0, 0, and the y position is 2.043, and at z position it is 2.043. So anyhow, when I export it, so this PDB file I can open in the what is this in the Vista to directly convert to take the positions simply. So here I will click on this export data, and here I will click this XYZ. Where is the XYZ? Here is the XYZ. Okay, so as you do. Do you want to save hidden atoms? So I will say no, because hidden atoms mean that it will show you more than 4 atoms position. So this is the XYZ file, and let me open it with the MS Word or Notepad. Sorry, yeah, WordPad or Notepad. So here you can see. So here you see here it shows 14 atoms. Okay, but export data and XYZ. Let me change. Okay. Do you want to save hidden items? So I say no. But here in this sector it shows 14 items, so there is something wrong. So usually these visualization software sometimes give you the wrong, show you the wrong number of atoms or wrong visualization. So if I open it in the VMD, here you can see this is the VMD, Visual Molecular Dynamics, and let me check it here. This is the original PDB file. So here you can see the atoms are 4. So I will show it here. Here you cannot see, but when I change the graphical representation, then you can see. So here in the display, I will click on the orthographic. So 4 atoms. So if I want to save these coordinates, so save coordinates, and I will click here XYZ and save this. So I will give the name silver dot xyz in the documents. So here now you can open it. So you can see here it shows the 4 atoms position, but this Vista shows 14 atom position. So this is sometime you need to be very careful that you know that your system has this much number of atoms, but the visualization software showed you basically the wrong result. Okay, so we can show it here. So this kind of problem sometime you will face. So you need to be very careful about your simulation study. Okay, so now I will take these coordinates and can write it in the CSTA format. So in the next video, I will show you that how to write CSTA input file, because this file, it is a free data format style, so you can write in the WordPad or Notepad or even in the MS Word. It does not matter, but the extension should be file name .fdf. Okay, so thank you very much. In the next video, I will show you how to write CSTA input file. Okay.